Okay, a couple of units back when we started talking about congruent triangles, we used something called CPCTC. It's kind of fun to say. If you remember, it stands for corresponding parts of congruent triangles are congruent. Okay, so that's CPCTC. Corresponding parts of congruent triangles are congruent. So that is actually the original definition of what it means for two triangles to be congruent. It means if two triangles are congruent, then all their corresponding parts, all their sides, and all their angles are congruent. So once you know triangles are congruent, all their parts also have to be congruent. So we're going to use this in proofs. If you can prove that two triangles are congruent, so once you've proved that two triangles are congruent, we know that all the corresponding parts must also be congruent. So you're going to do this where you have to prove two triangles are congruent, and then past that you have to say something like, so therefore if the triangles are congruent, then these two angles have to be congruent. Okay, so down here, these are examples of what the proof would look like, the given in the proof. So we want to look at these and decide which ones we'd have to use CPCTC and which ones we wouldn't. So the big hint here is if it has that you're proving that two triangles are congruent, you're not going to have to use CPCTC. So this one would be no. So looking through here and looking for the ones where I have to prove two triangles are congruent, that's no. That's here. So the rest of them, for this one, I'd basically have to prove that triangle, let's see here, triangle ADB is congruent to triangle, let's see here, CDB. It looks like, let's see here, how would we do that? BD is perpendicular to AC. DB bisects angle ABC, and that's congruent. We would use this by ASA. So once we know the two triangles are congruent, we can say A and C are congruent. Look, A is the first letter, C is the last letter. So this one, we'd have another step right after that in the proof. Let's see. So the two angles are congruent by CPCTC. So this one will be yes. This one we haven't learned about parallel lines, but I can see that it looks like we're going to have two triangles that are congruent, and then those corresponding parts would be congruent. Same for number 6. We'd say the two triangles are congruent, and then HM and AM would have to be congruent. Okay, so this was proving the angles of the triangle were congruent. Both of these were proving the sides were congruent. This one's different. Okay, for this one, we have to prove that C is a midpoint. So think about that. If C is a midpoint, that means that AC and CD would have to be the same. So basically what's going to happen is we're going to have to prove the triangles are congruent. Then we're going to have to say by CPCTC those two sides are congruent because they're corresponding parts of the triangle. And therefore, since the sides are congruent by the definition of a midpoint, that will be, C will have to be the midpoint. So this one is yes. This one's the most complicated of all of them, but we're going to do an example of it.